Use a ruler and a compass to draw an isosceles triangle with the following conditions. 1, at least one of the sides is 7 centimeters, and 2, at least one of the sides is 3 centimeters. Well, the first step is to look at your conditions. Both of them say at least 1, which means that it could be one side or more sides that meet the condition. Plus, since the triangle is isosceles, we know that 2 of the sides must be equal. So first, pick which number you would like to occur for 2 of your sides. Let's start with 7. So if we select 7 centimeters, we can draw one of our 7 centimeter segments by starting at 0 and drawing the straight line along the ruler and stopping at 7. Step 3. With your compass, draw a circle or a semicircle, whichever you prefer. So you line up your compass with your endpoints and you draw your semicircle. And with this arc that represents that semicircle, any segment that I connect from this arc to the center will have the same radius length of 7 centimeters. Step 4. With your ruler, find the segment that can be drawn from our endpoint that's on the circle, point B, to make another point on the semicircle so that the ruler measures 3 centimeters. So if we take our ruler and we line up 0 with B, and then we see, well, 3 is right here at this point. So I'm going to make that new point and I'll label it point C. And then the last step is to connect this point with points A and B. So you connect points B and C together with a segment and points A and C together to form your triangle. And we know that AC is equal to AB, which is equal to 7, since they are both radii of the same circle that had a radius and length of 7 centimeters. Here's a question to think about. Can we make a triangle if we use the 3 centimeter side twice and the 7 centimeter side once? Take a moment to pause this video and think about it, and when you're ready for the answer or think that you know the answer, you can unpause the video. This is actually not possible to have a triangle with 2 sides of length 3 centimeters and the third side be 7 centimeters, because if you remember, we have 2 sides, 2 segments that are 3. And then if this one is 7, then if I was to actually take my compass and straight edge and line it up here and draw my circles, I don't think that these are going to meet up. So if I take this, pretend that that segment is collapsing into the middle, and then we're going to do the same thing with this one. Set it up here. Pretend that this side is coming in, coming in, coming in, coming in. Oh wait, 3 centimeters and 3 centimeters are less than 7, so they're not going to come together and make a point for our triangle. So therefore, we can't make a triangle that has 2 sides of length 3 and the last side of the triangle being of length 7. Therefore, since the sum of the 2 smaller sides is not greater than the third side, we cannot create an isosceles triangle with 2 sides that are 3 centimeters long and the third side being 7 centimeters long. It's just not possible. Use a ruler and a compass to draw an isosceles triangle with the following conditions. At least one of the sides is 8 centimeters, and at least one of the sides is 6 centimeters. So let's first start off by picking which side we want to have occur twice, because an isosceles triangle has at least 2 sides that are the same. So let's start off with, say, 6. 6 is going to be the segment length that I'm going to have 2 of. So if I do that, let's get our ruler out. Let's measure 6 centimeters. Again, start at 0. We're going to make a point there, then draw out. We're going up to 6, which is right here. And then I can move my ruler out of the way because I don't need it right now. And we have our other point right here on the ends. And now let's get our compass. And we can take our compass and we're going to make our arc so that we can use it to create the other side that is of length 6 eventually. So we're going to create it. It'll be about a semicircle, or at least almost one. Okay, now we can move this out of the way. Okay, so now we have to take our ruler again, and we need to rotate it so that we get it to be able to measure 8 centimeters for our other side. So if I line up 0 with this point, right down here, right there, and then let's try to rotate this again. I'm going to stop when 8 centimeters intersects my circle. So I'm at 6, 7, and 8 is my arc. Okay, so right here is where that other point is going to be, right here. And then we're going to connect this directly to the point at the end. So we know that this is 6 centimeters, and this is 8 centimeters, because we just measured them. And now, because we also know that this distance from this point up to here where it intersects the circle is also the radius, we can take our ruler and just line it up. We don't have to measure anything. And we just need to connect these 2 points right here. So if we connect these 2 points, we know that this length is also 6 centimeters. So we can label it as 6 centimeters. So this is one of our conditions for one side is of length 6 centimeters, at least one of them, and at least one of the sides is 8. Well, what if we actually had 8 centimeters being used twice instead of the 6? Can we do that too? Let's actually try it. So first, let's start by making a point. Let's say right here. That's going to be our center. And then we're going to take this ruler and line it up, and we're going to measure 8 centimeters and go straight up with it. Okay, and then I'm going to stop right there. Pull this out, and I can label the other side here with this point. And then we're going to take our compass again, and we're going to bring our compass down and set the center point right there. And then we're going to extend it out until it gets to that point right here. And now we're going to draw an arc going through. Okay. So now we're done with this. We can put it again off to the side. We need our ruler again. And next what we're going to do is we are going to rotate this. And because it's rotating in this way, I want the one, there we go. We want the 0 to line up here. Now what we want is we want 6 to line up with the edge of the ruler, and that's right about, nope, almost. Here, 0, okay. And again, line it up right there. That's where it's going to be. And then I'm going to follow this path right here, and it stops at 6 right when it hits the circle. And then I can pull this off and then label this point right here. So we know this is 6 centimeters, this is 8 centimeters. And then if I connect these two right here, that value is also going to be 8 centimeters. So now that these are lined up, I can connect these. So these are the two possible answers that we have for these two triangles. And the reason that we could do both of these is because 6 plus 8 is going to be greater than 8, and then also 6 plus 6 is greater than 8. So we can make two different triangles that meet these conditions. So they're both accepted as possible answers. Okay, what this slide shows is the two triangles that are possible to be created under the conditions. At least one of the sides is 8 centimeters and at least one of the sides is 6 centimeters. So here it shows the first one that we created, and here's where the second one was that we created. If you would like more information about how to construct isosceles triangles in an interactive software program, please click on the link below in the bottom right-hand corner.